Hi learners, welcome to our lesson of today. Previously, we have been solving problem involving pressure in solid, but today in our lesson, we are going to start solving problems pressure in liquid. And here I have some 3 questions that I will take you through in solving. The first question, we have a diver is 10 meters below the surface of water in a dam. If the density of water is 1000 kilograms per meter cubed, determine the pressure due to the water on the diver. So solution, we have solution. First of all, I said that you must list what you have been given. From the question, we have 10 below the surface of water in a dam. So I can say that is question 1, height is given by 10 meters. Then we have density of water. Density of water given by 1000 kilogram per meter cubed. And we have been given also G, the force of gravity. G is equals to 10 Newton per kilogram. So we are being asked to determine pressure due to water. So water is a liquid. So pressure in liquid is given by taking density of a liquid times G times height. This pressure is not by P, then density is always not by rho, then G, then H. From the variables that we have been given, height I have it as 10, density as 1000, then G as 10. So pressure in water is given by density of water, then times G times the height of water. Remember this is liquid, but I'm just referring to water. So when you substitute in our formula, we have our density that is 1000 times G, which is 10, times the height, which is 10. So this one, it gives me 100,000 Newton per meter squared. So this is the pressure of that pressure of water experienced by that diver. Then for question 2, we have, for question 2, the density of mercury is 13,600 kilogram per meter cube. Determine the liquid pressure at a point 76 centimeters below the surface of the mercury. So question 2, what we have been given, we have the density of mercury. This is 13,600 kilogram per meter cubed. Then we have determine pressure at a point below the surface. So height given by 76 centimeters. Then we have G. G equals to 10 Newton per kilogram. We are being asked to determine the pressure, and I've said pressure of mercury is given by density of mercury times G times the height of mercury below. the surface, height of Mercury below the surface. Remember, we have been given the density, we have G, and we also have height. But this height is in centimeters. So we must convert this height back to the SI unit, that is into meters. So I can have here my working. We know that 100 centimeters is equal to 1 meter. So what about 76 centimeters? So you have 1 meter, or 76 centimeters times 1 meter over 100 centimeters. This one, it will give me 0.76 meters. So I have, this is my height in meters, I have density, then I have G. So I substitute in my formula. I have 13,600 times 10 times 0.76. So you can use our calculator to work it out. I have 13,600 times 10 times 0.76. That is 360 Newton per meter squared. This is the density, not density. This is the pressure of liquid that this mercury is experiencing. This is question 2. Then for question 3, we have calculate the pressure due to water experienced by a diver working 15 meters below the surface of the sea. Take G equals to 10 Newton per kilogram and density of the seawater equals to 1.03 grams per cubic centimeter. So as I've said, first of all, before you simplify or to solve that problem, you must state what you have been given. From the question, we have height. That is question 3. Height is 15 meters. Then we have G, which is equals to 10 Newton per kilogram. Then we have density of seawater. Is given by 1.03 grams per centimeter cubed. As I've said, pressure is given by density times G times height. Now, from what we have been given, we have density. Density is here. We have G, we have height. But remember, as I said, we must convert all these dimensions or the parameters back to the SI unit. Remember, the SI unit of density is kilograms per cubic meter. So we must convert this one into kilograms per meter cubed. So here, from the working here, we can have 1,000, we always say 1,000 kilograms per meter cubed is equal to 1 gram per centimeter cubed. So what about 1.03 grams per centimeter cubed? So we cross multiply. We have 1,000 times 1.03, then over 1. This gives me 1,030. That is 1,030 kilograms per meter cubed. This is density in kilograms. So I have density in kilograms in the SI unit. So I have height in SI unit. Then G is always constant and is always given. So we substitute in our equation. So I have our density 1030 times 10 times the height, which is 15. Which is 15. So we use our calculator. We have 1,330 times 10 times 15. That is 154 500 Newton per meter squared. So this is the answer for question 3. So we are done with the working of these questions, and I would like to give you an assignment that you can try when you are at home. So you can write. These are the questions that I would like you to try when you are at home. The first question, it says the atmospheric pressure at a place was measured as 740 millimeter of mercury. Calculate the pressure at the place in pascals. So I have been given the density of mercury as 13.6 grams per cubic centimeter. Then question 2, express 76 centimeters Hg in newtons per meter square. Then state the last question, state the two main factors affecting pressure in liquid. So these are the questions that I would like you to try when you are at home. This marks the end of our lesson today. May God bless you, and let us meet during the next lesson. Bye-bye.